In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 2-1. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video as you need to. If you're looking for a different question from this paper or a different paper entirely, have a look in the description below. You should be able to find a playlist there or have a look around on my channel. Okay, let's get into the maths. In question 4, we're given this diagram and this equation, and we're asked to find the exact coordinates of the maximum point, the x coordinate. So we really just want the x number of this maximum point here. Of course, we see maximum point, we hopefully are thinking dy dx equals 0. Dy dx equals 0. That's going to get you part of the way to 1 mark just by writing that down. So what they're asking us to do is to differentiate this function here. Let's do it over here. It's not that easy. Some students can do it in their head. You know what I'll do is I'll differentiate this first one here really slowly using substitution, and then I'll do them both a little quicker. I'll show you the shortcut that might do both of them. So forget that for a moment. Let's just come over here and look at a whole new function, 6e to the 2x. To differentiate this, it's a little complicated. We know how to differentiate e to the power of x. It's really easy. It's just e to the power of x. So if I change this up and I substitute some of this, I put u is equal to x. You can do all this in your head. You wouldn't usually write all this. This function becomes y is equal 6 to the e to the u. Using chain rule, this is quite easy to differentiate. Dy dx is equal to dy du multiplied by du dx, because these cancel each other. It's the same thing here. And what this really says is differentiate this with respect to u. It just becomes 6e to the u. And then differentiate u with respect to x. That just becomes a 2. Putting all that together, we get 12e to the power of u, which is e to the 2x. Now, we could have done that quite quickly by just saying the derivative. Yeah, let me write this again. This is how I would do this. I would just say the derivative of e is just leave it alone. It's just 6e to the 2x. Except I have to multiply by the derivative of what I just forgot was there. I forgot this was complicated. And if I multiply by the derivative of that, I get my final answer. So I just multiply by 2. Or usually I do all that in my head and just say 12e to the 2x. So I'd look at this and I'd say, well, let me do this half slowly. 6e to the 2x multiplied by a 2. And that 2 is coming from the derivative of here. Doing this one here is minus e to the 3x multiplied by 3. That 3 is the derivative of up there. That's how I do it. If you wrote this, it'd be fine. The examiner would know where you're getting this shortcut from, or that's the longer way to do it. Clean this up, we get 12e to the 2x minus 3e to the 3x, and all that's equal to 0 because we're looking for the maximum point. So let's rearrange this. 12e to the 2x is equal to 3e to the 3x. Now, there's a couple of ways to solve this, but nicely later on in the question we have to solve something similar again. So I'll do it one way now and one way later, and we'll see what we get. You'd be forgiven if you see e, just think, well, natural log destroys e. So I take the natural log of both sides. That's 12e to the 2x is equal natural log of 3e to the 3x. The problem, natural log can't destroy this e because the 3 is in the way and the 12 is in the way. So that's a slight issue. But we just look up our rules for logs. When a log has two things multiplying inside it, it works quite nicely. It's just log 12 plus log e to the 2x is equal log 3 plus log e to the 3x. That works out quite nicely. That's log 12 plus 2x, because the natural log and the e now do destroy each other, is equal log 3 plus 3x. We clean that up. I'll do it over here. All the x's on one side, all the natural logs on the other. we get 3x, well let me write it out, 3x minus 2x is equal, let's see, natural log of 12 minus natural log of 3. That'd be x is equal, well natural log, the same rule that broke these apart, can put them back together. Take away is just like divide. This is the natural log of 12 divided by 3. You could have also just 12 divided by 3 all the way back here as well to get a 4, to get your final answer as well, natural log of 4. That's your answer for part A. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Now for part B, they want us to find the shaded region in here. Let me just write down the answer from part A, that's natural log of 4. This would have helped me when I did the question first, because I made a big mistake that I'm guessing some students probably made. Let me write out the mistake I made and see if you notice it too. Okay, so the shaded region of this, hopefully you're thinking integration. So what we're going to look for here is the integral. I have to check my notes to remember the formula. 6e to the 2x minus e to the 3x. We need to integrate this to find the area. We need to integrate it between 0 and natural log 4. Do you see the mistake? I'm guessing one or two of you probably made the same mistake as me. It's not between 0 and natural log 4. It's between 0 and whatever this number here is. I think the examiner probably did that on purpose. They knew your answer from part A would be in your head. You'd think, just put it straight in. I messed up. I did it through and was just double checking my answer and I was like, what happened? I instantly see where that. So the first thing you need to do before doing this integral, you need to find what this number is here. So we do that by putting y equals 0. So we know y is 0 and we know y is equal to 6 e to the 2x minus e to the 3x. So we just need to solve this. It's quite like what we did in part A. Move this around, we get e to the 3x is equal to 6 e to the 2x. Last time I got natural log of both sides. Let me do this one a little different. Let me play around with the powers this time. This is the same as e to the x to the power of 3. And this is the same as e to the x to the power of 2. I'm just using the rules for powers instead of the rules for logs. If I divide e to the x squared over, let me write it out a bit slower. E to the x, there's 3 of these, and I'm going to divide by these two. E to the x, there's 2 of these. They cancel in, they equal 6 first of all. They cancel in and we're just left with one of them, e to the x. 2 cancels in and we're just left with e to the x to the power 1, e to the x to the power 1. Just take the natural log of both sides now. Natural log of 6 is equal x. That's the number we're looking for here, natural log 6. That's the number that should be up here. Now we can start finding the area. Alright, let me clear this bit off and I'll continue to do the question I should have done. Just like I did previously, you can do this quite quickly in your head. You're actually going to just end up leaving this alone and dividing by the derivative up here. But let me do it slowly one more time. I'll do the first one quite slowly. Again, I'll use substitution. The idea that u is equal to this 2x up here. And you could do it with 3x as well. But again, we'll do it quickly after showing you the first time. If this is substitute, the derivative of this, which we're getting so I can find out what to replace dx with. Although it's a bit confusing here because what I'm actually just doing is half of this. I'm ignoring that guy. Hopefully that's clear. This is equal to 2. When this is just a constant, in differentiation it works no matter what, but in integration it only works when it's a constant. You can just divide by it because all the x's are gone in this second one. So that'd be dx is equal to a half. That's where we get divide by 2 du. So yeah, let me change this here. All I'm doing is this right now. and that would become the integral of 6. Well, the 6 can come outside the integral. 6 e to the u multiplied by a half du. I'm replacing the dx with a half du. And again, the half can come out. We get 3 integral e to the u du. The integral of e to the u is just e to the u. That's the special thing about e. Its integral and derivative is the same as itself. So the answer is e to the u, or e to the 2x, because that's what u is. So the integral of this guy is just this. Let me do the whole question again. This time I'll do it quickly in my head using what we learned here. So we were doing the integral between natural log 0 and natural log 6 of, let's see, 6e to the 2x minus e to the 3x with respect to x. So the integral of this is just 6e to the 2x divided by the derivative of whatever's up here. So the derivative of 2x is just 2. Minus e to the 3x divided by 3, because it's the derivative of 3x. And this is just evaluated between 0 and natural log 6. We can clean this up slightly. 3e to the 2x minus 1 over 3e to the 3x. Again, this is evaluated between 0 and natural log 6. So let's just start filling this in. Natural log 6 goes in here. 3e 2 times natural log 6 minus 1 over 3e 3 times natural log 6. And then we put 0 in and we take that away. Minus 3e 2 times 0 is 0. Minus minus is a plus. 1 over 3e to the power 0. We need to do a little bit of work with the logs. 2 natural log 6. Your calculator will tell you, but it's also, this 2 can move in and become a power up there. So it's actually just natural log 36. E and the natural log destroy, so we're just 3 times 36. Do you see where I'm getting the 36 there? That's 6 squared. Same here, it's 6 to the power of 3. So this is minus 1 over 3 e to the natural log destroy, and we'll just have a 6 to the power of 3, which I'll have to just double check my notes. I want to say 200 and, yeah, there it is there, 216 minus 3 plus a third. I guess we put everything over 3. This over 3, multiply up here by another 3. That's already over 3. This over 3, multiply this by another 3. And put all this together. This be 9 multiplied by 36, which would be 270 plus 9 sixes is 54. 324. Apologies if that's wrong. I'm going to correct it in a minute because I've just used the answer I got down there. But 324 minus 216 over 3 minus 9 over 3 plus 1 over 3. Let's see, there's 100 between these two, plus another 8. So 108. Take away 9 is 99. Plus 1 is 100. So I think I did have the right number here, because that is the final answer that I have there. 100 divided by 3 is the total area between 0 and natural log of 6. Okay, they wanted the answer in the form of p over q, where they're both integers. That works fine. That's the answer to question 4. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.